All right, in this lesson, we are going to be learning about inverses and inverse functions, inverses of relations. So really, there's three parts to this that we're going to learn. We're going to learn how to find the inverse. We're going to graph or see relationships between the graphs of inverses. So as we work through, we'll be graphing a few things and you're supposed to kind of recognize something. And then last, we'll see relationships between the composition of inverse functions. So those are the three things we're going to be looking at. So here is the definition of inverse. If a relation R contains the ordered pair AB, its inverse relation, and this is how we denote the inverse relation, R with a little -1, contains the ordered pair BA. So really what you're doing is you're switching the X value and the Y value. And that is what's stated right here. This is very important to find the inverse of a set of ordered pairs. Switch the X and Y values in each ordered pair. And that switching of X's and Y's is going to be the main theme for finding inverses. So looking at this example here, we have, and I'm going to rewrite this, we have the relation Q with all those four ordered pairs that describe the vertices of a quadrilateral. Find the inverse of Q, then graph both quadrilaterals on the same graph. What is the relationship? So just so we can see this a little better, Q is 2, 1, 4, 1, 6, 2, and 5, 4. Which means the inverse, which I'll put here in red, so we put Q with a little -1. All we're going to do is switch all the X and Y values. So we're still going to have 4 points. So switch 2 and 1. So we would have 1, 2. Switch 4 and 1. So 1, 4. Switch 6 and 2. So that would be 2, 6. And switching 5 and 4 would give us 4, 5. It asks us to graph both of those. So let's start with the original, the green. So the point 2, 1, I'm going to enlarge this here. The point 2, 1, over 2 up 1, 4, 1. It's here. 6, 2 is here, and then 5, 4 is here. So we want to connect them in the order they were listed. So that was 2, 1 to 4, 1 to 6, 2 to 5, 4. And then we can go back to the starting point. And now let's do the inverse. So we have 1, 2 to 1, 4. So we're graphing this 1, 2, 1, 4. 2, 6, and then 4, 5. And we connect those. If you look at this, this is a reflection. They're the same shape, same size. It's actually, if you look at this, take this line right here. That's the y equals x line. The inverse, so the red is a reflection over the y equals x line, and that's what we want to notice about the inverse of the graphs of inverses. So that's pretty cool. Next part here, to find the inverse of an equation. So the first one was to find the inverse of a set of ordered pairs. We switch the X and Y values in each ordered pair. To find the inverse of an equation, you switch X and Y and then solve for Y. So still the same idea of switching X and Y. So find the rule. So example 2, find the rule for the inverse of each function, then graph each on the same coordinate plane. So we'll start over here with part A. We want to find the inverse. Well, it says to switch X and Y, and there's no Y here, but we do know that f of x is the same idea as y, so we have y equals 3x minus 6. It does say to graph each, so let's just go ahead and start by graphing this one. We'll graph it in black. So we know this is a line that passes through -6 on the y-axis, and it has a slope of 3, which we like to think of as 3 over 1. So slope up 3 over 1. We'll put several points on here. Not always the best at drawing lines on here, but we'll do my best here. So there is that line. Now we want to find the inverse. Well, the inverse is going to be, we switch x and y. So we'll have x equals 3y minus 6. Well, this is not in the form of a line that we want, so we're going to go ahead and solve for y. So we could add 6 to both sides. And that gives us x plus 6 equals 3y. Dividing both sides, or each term really, by 3 gives us 1/3 x. So x over 3 is 1/3 x. And then 6 over 3 is 2 equals y. We like oftentimes to put the y first, so y equals 1/3 x plus 2. Let's graph that. This is our y-intercept at 2. And we have a slope of 1/3. So up 1, right 3, 1. And so this graph would look something like this. So the inverse of a line is still a line. Let's take a look at something we mentioned with that quadrilateral earlier. It was reflection over the y equals x line. And it looks like it's the same thing, so that seems to hold true. All right, this next one is a parabola. Let's go ahead and just graph that to start with. X squared plus 1, we know that's a parabola moved up 1. And then we can graph for other points. If you need to, you can use a table of values, or you can use the idea we learned before, up 1, over 1, up 1 squared, over 2, up 2 squared. And over 3, up 3 squared would put us there. Parabolas are symmetric, so we can do the same thing on the other side. And here is the graph of our parabola. Well, let's find the inverse. So the inverse, this is the same idea as y. So our inverse will be x equals y squared plus 1. And we're going to solve for y, so we would subtract 1 from both sides. That gives us x minus 1 equals y squared, and we have to take the square root of both sides. When we take the square root, we have to put plus or minus. So we have y equals plus or minus the square root of x minus 1. Well, we did graph these before, so this is the same thing as having two equations here. We want positive square root of x minus 1 and negative square root of x minus 1. So we're going to graph these two things. Actually, we're going to graph them in red. Sorry about that. They'll be in red. So this first one, this is, if you remember, square roots. They're half a parabola going sideways, and this one is moved right 1. So right 1, that's going to be here. So that's that one, and then let's do this next one in orange. It's going to be the same thing, except we have this negative, so it's going to be flipped upside down. So it's going to be here. So there is they're on the same coordinate plane, and once again we see that it is a reflection. Oops, I goofed here. This is in the wrong spot. It's moved right one. I moved it right one and up one. It's moved right one, so it should be moved right here. Oh, should be there and here. I was going to do it in red. And so there's the inverse. So sorry about that mistake. And notice, now we can notice this is a reflection over this y equals x line once again. So in each of those, as we zoom out, you see that to talk about the graphs of the inverse functions, the graphs and inverse relation or function, because, and the reason why I don't just write function is because this red one right here was not a function, doesn't pass the vertical line test, is a reflection over the y equals x line. And hopefully you notice that that y equals x line is the one that splits the first quadrant and the fourth quadrant in half. All right, domain and ranges of inverses. Well, this will fit with the switching x and y. We switch x and y. Well, x has to do with the domain and y has to do with the range. So if we switch them, they'll be switched for the inverse as well. So the domain of a function is the range of the inverse. And the range of a function is the domain of the inverse, because we're switching the x and y